Hello, good morning and welcome to For Knowledge. In today's introductory session, we'll be learning about matrix multiplication. Now before we go on into matrix multiplication, first we need to learn what are matrices and what are its rows and columns. So matrix is nothing but an arrangement of numbers into rows and columns. What is matrix? Matrix is nothing but an arrangement of numbers into rows and columns. Suppose we are taking 6 numbers 1, 2, 3, 4, 5 and 6. Now we can arrange them like this way. One is 1, 2, 3, 4, 5, 6. This can be one way. We can arrange them like this. 1, 2, 3, 4, 5, 6. Or we can arrange them like this. 1, 2, 3, 4, 5, 6. Now all of these arrangements are either in some rows or in some rows and columns, in the combination of rows and columns, or we can arrange them like this, only in columns. We can also arrange them like this. So the first one we are naming it as A, the second one as B, the third one as C, and the fourth one as D. Fine. So all of them can be regarded as matrices. All of them can be regarded as A is a matrix, B is also a matrix, C is also a matrix, D is also a matrix. Now I have mentioned two terms, rows and columns. Two terms, rows and columns. This horizontal arrangement, these are called rows, fine, and these vertical arrangements, these are called columns. The horizontal arrangement is called rows and the vertical arrangement is called columns. Now how many columns are here? Here are 6 columns. Column 1, column 2, column 3, column 4, column 5 and column 6. How many row is in here? There is only single row. There is only single row. So this matrix A has single row and 6 columns. Similarly, matrix B has 2 rows, number 1, row number 1, and this is row number 2. But there are 3 columns, column 1, column 2, column 3. Now in this matrix there is only single column. There is only single column, but we have 6 rows. Row 1, row 2, row 3, row 4, row 5 and row 6. In D there are 2 columns and 3 rows. Okay. So the horizontal arrangement is called row and the vertical arrangement is called column. I hope this is clear. So a matrix means vertical, that means in column we can arrange numbers, also in rows, that is horizontal, we can arrange numbers. Okay. So matrix means any kind of arrangement in between rows and columns. That is how we define matrix. I hope this is clear. Now we will be moving into matrix multiplication. Now matrix multiplication means there must be at least 2 matrices. Multiplication is a binary operation. Multiplication is a binary operation. That means you need at least 2 matrices in order to perform the matrix multiplication. Let it be A and B. There are 2 matrices A and B. We need to perform their multiplication. Now before we go on to multiplication, we need something about the compatibility. Okay, we need something to know about the compatibility of the multiplication. Okay, compatibility means whether the multiplication can be done or not. Okay, so suppose A has n number of rows and m number of columns, COL means columns, and B has p number of rows and q number of columns Fine. Now listen very carefully. There is a condition for the compatibility. What is the condition? The condition is, if we are about to find AB, that means A into B, that means where A is the pre-multiplier and B is the post-multiplier, where A is pre-multiplier and B is post-multiplier. So for this to be defined, for A into B to be defined, we must have number of columns in A should be equal to number of rows in B. Is this clear? We must have A into B to be defined or compatible. We must have number of columns in A, that is number of columns in pre-multiplier should be equal to number of rows in post-multiplier. Fine. That means in this case, in the above example, we must have M should be equal to P. We must have M should be equal to P. Otherwise we cannot define or cannot perform the multiplication. Got it? Now, had it been the case like B into A, suppose we had to multiply B into A, then which one is the pre-multiplier? B becomes the pre-multiplier and A becomes post-multiplier. So in this case, the form is again same. The formula is again same. That is, number of columns in B should be equal to number of rows in A. Okay? That means number of columns in pre-multiplier should be equal to number of rows in post-multiplier. That means in this case, B has Q number of columns should be equal to A has n number of rows, Q equal to n. Got it? Very simple concept, nothing difficult. You must remember that number of rows in number of columns in pre-multiplier must be equal to number of rows in post-multiplier. That is what you need to remember. Now if this is okay, then we are going into some multiplication. Okay, how to perform the multiplication. Fine. First of all, if two matrices are given and you have to perform the multiplication, then you need to verify the condition first. Okay, suppose A is 1, 2, 3, 4, 5, 6 and B is 2, 0, 1, 3, 7, 2. Multiply AB. First you tell me, is it possible or not? First you tell me, is it possible or not? Number of rows in A is row 1, row 2. Number of columns in A is 1, 2, 3. Number of rows in B 1, 2. Number of columns in B 1, 2, 3. So we need to check in order to check whether AB is defined or not, we need to check whether column of pre-multiplier equal to row of post-multiplier or not. Now column in pre-multiplier is 3, row in post-multiplier is 2, clearly 3 is not equal to 2, so AB is not defined. We cannot perform the multiplication. Got it? That's how we check whether a multiplication can be done or not. Now let's move on to a second example. Now we can also check whether BA is defined or not. BA is defined or not. Now in order to BA to be defined for multiplication, we must have columns in B, that is 3, should be equal to rows in A, that is 2, which is not equal to 3 is not equal to 2, so B into A is also not defined. B into A is also not defined. Okay? Fine. So now let's move on to some proper examples. Suppose A is 1, 2, 3, 4, 5, 6 and B is 2, 1, 3, 0. Here we have 3 columns, so it must have 3 rows, 1, 7. Okay, now multiply AB. Now A is the pre-multiplier here and B is the post-multiplier. So A has 3 columns and B has 3 rows. B has 3 rows. So 3 is equal to 3. That means this multiplication is defined. Fine. So now let's move on to the multiplication. A into B. That means 1, 2, 3, 4, 5, 6 into 2, 3, 1, 1, 0, 7. Okay. Now there is another one thing, that is, if we are to multiply AB and suppose AB is defined with A has n rows and m columns and B has some p rows and q columns. Then of course, since AB is defined, we have mentioned that, so m should be equal to p. And the final output, that means the AB matrix. The AB matrix will have number of rows is n and number of columns is q. Okay. So AB matrix will be having the number of rows as the number of rows in pre-multiplier and number of columns as the number of columns in post-multiplier, that means in B. So NQ, this will be the order of AB. This will be the order of the final matrix AB. Now here A has 2 rows, row 1 and row 2, and B has 2 columns, column 1 and column 2. Okay, that means here n is 2, in this case n is 2 and q is also 2. So the final output, there will be 2 rows, row 1, row 2 and 2 columns, column 1 and column 2. Okay, in final matrix AB will be having 2 rows and 2 columns according to this concept. Fine. So now let's move into the multiplication. How we multiply? We multiply according to the row of first matrix, that means pre-multiplier, and column of the post-multiplier. Okay? We multiply along the row of pre-multiplier and the column of post-multiplier. Fine. Now which row and which column to be calculated? Which row and which column to be considered? Now look, in this place, it is the element of row 1 and column 1. It is the element of row 1 and column 1. So in order to calculate this place, we must have this row 1 of pre-multiplier and column 1 of post multiplier. Okay, so 1 1, row 1, column 1. Fine. In case of this is row 1, column 2. This is row 1, column 2. Okay, so for row 1 we must have to consider this row 1 of pre-multiplier and column 2 of post multiplier. Column 2 of post multiplier. Row 1, column 2. Row 1, column 2. Okay, so we have to consider row 1, column 2 for this place. For the third one, this is row 2, column 1. This is row 2, column 1. So row 2 of pre-multiplier and row 1 of post multiplier. Sorry, column 1 of post multiplier. Row 2 of pre-multiplier and column 1 of post multiplier. Row 2, column 1. And the fourth one, row 2, column 2. So row 2 of pre-multiplier and column 2 of post multiplier. Row 2 of pre-multiplier, column 2 of post multiplier. Fine. Now multiply element wise and then add them. Multiply element wise and then add them. How this works? Look, I am just erasing this thing so that the board is not too much congested. 1 2 3 4 5 6 into 2 3 1 1 0 7. Fine. For row 1, column 1, the first element, row 1, column 1, what we have to do? We have to multiply row 1, column 1. Row 1 of pre-multiplier, column 1 of post multiplier. Fine. Multiply element wise. That means 1 into 2. 1 into 2. 2 into 3. 2 into 3. Element wise multiplication. Then 3 into 1. 3 into 1. Now add them. Fine. For the second one, row 1, column 2. Row 1, column 2. So row 1 of pre-multiplier, column 2 of post multiplier. Element wise multiplication. 1 into 1. 2 into 0. 2 into 0. 3 into 7. Add them. Now row 2, column 1. Row 2, column 1. Row 2, column 1. Row 2 of pre-multiplier, column 1 of post multiplier. Element wise multiplication. 4 into 2 plus 5 into 3 plus 6 into 1. Simple. And finally row 2, column 2. Row 2 of pre-multiplier, column 2 of post multiplier. 4 into 1 plus 5 into 0 plus 6 into 7. Calculate them. 2 plus 6 plus 3. 2 plus 6, 8. 8 plus 3, 11. 1 plus 0 plus 21. 1 plus 0 is 1. 1 plus 21 is 22. 8 plus 15. 8 plus 15 is 23. 23 plus 6, 29. And finally 4 plus 0, 4. 4 plus 42, 46. This is the final answer for AB. This is the final answer for AB. I hope you understand the problem. Let's take another problem. Now you tell me, what is the order of A? Order means number of rows, number of columns. A has look 3 rows and 3 columns. We have 3 rows, 1, 2, 3, 1, 2, 3, and 3 columns, 1, 2, 3. So A has 3 cross 3 order. B has 3 rows and 3 columns. So B also has 3 rows, 3 columns. Now, if you look carefully, then both AB and BA, both of them are compatible. That means both of them can be multiplied, or the multiplication can be operated for both of them. Because in case of AB, A has 3 columns, B has 3 rows. So number of column equal to number of rows. Fine. So it is defined. And on the other hand, B has 3 columns, A has 3 rows. So in case of BA, 3 equal to 3, that means BA into A is also defined. Now let's perform AB. Let's first perform AB. So AB will be a matrix of order 3 cross 3. AB will be a matrix of order 3 cross 3 because it has 3 cross 3. BA also has 3 cross 3. So AB will have 3 cross 3 order. That means 3 rows, 3 columns. Now AB into B equal to 3, 1, 2, 2, 4, 6, 1, 3, 7 into 2, 1, 6, 4, 8, 0, 5, 3, 1. Now let's multiply. How do we multiply? We multiply along row of the first matrix or pre-multiplier and column along the second matrix or the post-multiplier. Now, for the first row, first column, column 1, column 2, column 3, row 1, row 2, row 3. For first row, first column, we multiply along the first row of pre-multiplier and first column of post-multiplier. So 3 into 2, 6, plus 1 into 4, 4, plus 2 into 5, 10. First row, first column, row 1, column 1. Fine. Second one, row 1, column 2, row 1, column 2, row 1, column 2, for row 1, column 2. So 3 into 1, 3, plus 1 into 8, plus 2 into 3. For the last one, row 1, column 3, row 1, column 3, row 1, column 3. So 3 into 6, 18, plus 1 into 0, 0, plus 2 into 1, 2. Fine. Now for the second one, row 2, column 1. So row 2. Now this is in action. Row 2 of the pre-multiplier is in action. So 2 into 2, 4, plus 4 into 4, 16, plus 6 into 5, 30. Now, row 2, column 2, row 2, column 2, 2 into 1, 2, plus 4 into 8, 32, plus 6 into 0, 6 into 3, 18, 6 into 3, row 2 column 2 18. Now row 2 column 3 1 into 6 6 plus row 2 column 3 2 into 6 12 plus 4 into 0 0 plus 6 into 1 6. Okay, so row 2 done. Now row 3 is in action. Row 3 of 3 multiplier is in action. So row 3 column 1 column 2 column 3. So row 3 into column 1 row 3 column 1 1 into 2 2 plus 3 into 4 12 plus 7 into 5 35. Fine. Next row 3 column 2 1 into 1 1 plus 3 into 8 24 plus 3 into 7 21. Fine. And the last one row 3 column 3 1 into 6 6 plus 3 into 0 0 plus 7 into 1 7. Now add them, get the result. 10 plus 10 20, 11 plus 6 17, 18 plus 2 20, 20 plus 30 50, 20 plus 52, 20 plus 32 52, 12 plus 6 18, 14 plus 35 49, 25 plus 21 46, and the last one is 13. This is a 3 cross 3 matrix, 3 rows and 3 columns. So this is AB. This is AB. I hope this is clear. Now I am giving one task, that is you find on your own what is B into A. You find on your own what is B into A. B into A means first you have to write this matrix, then you have to write this matrix and go on multiplication like this one only. First write this 216 480 531, then 312 246 137, and perform the way we performed here, and then we will get B into A. Since B into A is defined, we have already shown you. I have already shown you, so I think it won't be that much difficult to find B into A. So please complete the task and let me know what is the result. So I hope you enjoyed the video. If you have enjoyed the video, please like and subscribe the channel. Thank you.